This video is over lesson 100, solving quadratic equations by graphing, and it's for my Algebra 1 class. So ladies and gentlemen, in order to use graphing to solve, first we need to understand that for quadratic equations of the form ax squared plus bx plus c equals 0, so standard form, the zeros, which are really just the x-intercepts, of the related quadratic function, which basically just replaces the 0 with f of x, are the solutions of the equations. So the zeros of the related function are the solutions to the quadratic equations. So if we graph it out, wherever the x-intercepts are, those would be the solutions to your quadratic equation. So to solve by graphing, one, we're going to graph the quadratic function, the related quadratic function. Two, we're going to use the graph and we're going to guess about where the zeros are. And then three, we're going to check that those actually are zeros. So to help us with this, we are going to take a look at the practice problems. So if you'd open up your books to page 673, please. And I'm actually not going to do these on line paper. I'm going to do this on my dry erase board here. So my first equation is 3x squared minus 147 equals 0. So first and foremost, remember that we need it to be set equal to 0 to be in standard form, so that's good. And then basically, the related function gets rid of the 0 and puts f of x in. Now I'm going to show you a little trick here, which can make our lives easier. We just need something set equal to 0. Well, it stands out to me that 147 is divisible by 3 using the divisibility test where I add up all three digits. 1 plus 4 plus 7 is 12. So actually, I could divide both sides by 3 and get x squared minus 49 equals 0. It turns out that since these two equations are equivalent, whatever the solutions to this are, the solutions to that will be as well. So if I make this my related function, then I get to work with slightly smaller numbers. So remember, ladies and gentlemen, when it comes to graphing, you may want to grab your handout here, graphing quadratic equation or function, excuse me. So we're going in standard form. So we need the axis of symmetry, negative b over 2a. So in this case, b would be the coefficient of the x term, or the linear term, which we don't have anything, so that would be 0. A would be 1, so this would be a negative 0 over 2 times 1. That's really just 0. So my axis of symmetry will actually be the y-axis. So if I have my y-axis here, oops, I know then my vertex is going to be somewhere there on the y-axis. And I can make that a little nicer. There we go. Now if we plug in 0 for x then, so 0 squared would be 0, minus 49 would be a negative 49. So then down here, let's go 1, 2, 3, 4, 5, 6, 7, and we'll call that negative 49, and that negative 7, negative 14, and so on, so on, so on, so on. So my vertex is down here. Now, I need to plug in some other points and find some values here. So maybe I plug in 1, 2, maybe 3. So if I plug in 1 squared is 1, minus 49 would be a negative 48. And then that'll be symmetric on the other side. So my negative 1 is going to be about right there. So it kind of blends with my 49 a little bit. 2 squared would be 2 squared would be 4, minus 49 would be a negative 45. So that'd be kind of there. So not really seeing a lot of it here. Sorry, sometimes a little hard to do this well on a dry erase board here. So that's better. So symmetric to that, -2, kind of out there. Basically what we're going to do is we want to get enough points that we can kind of see the curve here. So maybe I jump up to 5. So let's see what happens if I plug in 5. So 5 squared would be 25, minus 49 would be a 24. So this would be a -21, and so a -24 would be right about there. So symmetric to that, boom, 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 boom. So this is pretty wide. It's pretty wide. And so what we want to do is, to the best of our ability, we want to kind of come and make our parabola. And that's step 1. So now step 2, remember step 2 is we're going to use this to guess about where the zeros are. So I'm looking at this and I see, okay, 1, 2, 3, 4, 5, 6, kind of somewhere between 6 and 7. -1, -2, -3, -4, -5, -6, -7. Again, somewhere between -6 and -7. So between +6 and +7, between -6 and -7, I'm going to guess about there. So now it should be pretty obvious here. If we plug in 6 or -6, then we subtract 49, we're not going to get the 0 that we're looking for. But if I plug in 7, 7 squared minus 49 would be 49 minus 49, which would be 0. So 7 actually does work. F of a -7 would also produce 49 minus 49, and therefore 0. So 7 and -7 are my zeros, which means that 7 and -7 are the solutions to the equation up here. And so that's what the book is basically asking you to do, is to go through like that. Okay. We're going to take a look at B. We're going to take a look at B here. So 5 squared minus 6 equals 0. So the related function then would be that. So again, my axis of symmetry, remember, is a -b over 2a. So again, I don't have a b. If you don't have a b, it's going to be 0. So again, we're going to be on the y-axis. So if I plug in 0, I'll have a -6. So 1, 2, 3, 4, 5, 6, -6. And now let's try plugging in 1 and 2, and then we can go symmetric to that. So I plug in 1. 1 squared would be 1, times 5 would be 5, and then 5 minus 6 would be a -1. So right there. And then symmetric, it'd be right there. Now plug in 2. 2 squared is 4. 5 times 4 is 20, minus 6 would be 14. So 1, 2, 3, 4, 5, 6. I'm going to have to kind of extend this. So that was my 6, 7, 8, 9, 10, 11, 12, 13, 14. It's way up there. So 2 is way up here, and 2 is way up there. And so I would have something like this. Now here, we should be able to see, if I've drawn this correctly, that we're not quite on a whole number. And so if you plug 2 in, we know that it's too high. If we plug in 1, we know it's too low. So at this point, I would start making guesses and look for something that's close. Only I just realized that I made a little mistake in my graph. And I copied the equation down wrong. It was supposed to be a plus. So I'm going to go back and do it real quick here. And actually, I don't have to do much to figure out what's going to happen here. Because again, I'm actually going to have the same axis of symmetry because I don't have a b. So I come up here to 6. For my vertex. Because this is positive, it's going to open upwards. And so because of that, I know that this actually is going to have no real solution. No real solution. So I don't even need to get to the point where I start plotting out other points because I know it's going to open upwards. It'll never hit the x-axis, won't have any zeros, doesn't have any real solutions. All right, and if we check out the last one, x squared minus 10x plus 25 equals 0. So again, the related function would be f of x equals 0. So this time, I do actually have a b, so I need to consider what my axis of symmetry would be here. So it'd be a negative 10 over 2 times 1. Well, the negatives will cancel, and then of course 2 times 1 is 2, and 10 divided by 2 is 5. So my axis of symmetry here goes through x equals 5. So if we plug in 5 squared is 25. 10 times 5 is 50. 25 minus 50 would be a negative 25. Plus 25 would be 0. So actually, my vertex is going to be on the x-axis. Now, because my leading coefficient is a positive 1, that means from here, it's going to open upward. So therefore, there's only one solution here, and it's 5. So if the vertex is on the x-axis, we have just a single solution. Now, ladies and gentlemen, the reason why I'm doing this on the board and going over it quickly is, one, we've done in a previous lesson here, we've done graphing, and this mostly is really just guess and check. So you can graph your equations out, you can go through and guess and check a value, but I think there's a more important skill for us to be working on right now. And so I want to take the rest of this video to review the quadratic formula. And so this is a more algebraic way as opposed to a graphical way of solving for those zeros. So the quadratic formula actually comes in 2 parts, and most people just memorize the first part and forget about this. Memorize the second part and forget about the first. But the first says if ax squared plus bx plus c equals 0. So this requires us to have our quadratic equation in standard form. Then, and I want you to make this double big just so it really is very visible, then x equals a negative b. And then this is eventually going to be all over 2a. So remember, this is just like our axis of symmetry, but then we put something else in there because it is symmetric. Since it's symmetric, we put in a plus minus, so we go a little bit to the right and a little bit to the left of that axis of symmetry. And how far do we go? Well, the square root of b squared minus 4ac. And so the way we typically say this is that if ax squared plus bx plus c equals 0, then x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is what we're going to use to actually solve a. So A says 3x squared minus 147 equals 0. So using the quadratic formula, first of all, I need it to be in the form of ax squared plus bx plus c equals 0. So it is equal to 0. That's good. And so the x squared coefficient is my a. So a is 3. My x coefficient is b. I don't have any, so that means that b is 0. And then my constant is c. So negative 147 is my constant. That's c. So therefore, x equals, now a negative b in this case would be a negative 0. And we don't really need a negative 0, so we can actually just leave that off. But we will have a plus minus the square root. Now here I'm going to have 0 squared, which again we don't really need since it's 0. So we'll just have a negative 4 times a, so that's 3, times c, which is negative 147. And then all of that will be over to a. Now, in the radical, the two negatives will cancel each other out. That's good news. That means we're going to have an actual positive answer. And now we just work on simplifying. So I would grab my calculator here, and I would type in 4 times 3 times 147. And so we get that this is plus or minus the square root of 1,764 all over 6. And then if I take the square root of 1764, that's 42. So this is plus or minus 42 over 6. And of course, 42 divided by 6, plus or minus 7, which is exactly what we got with the graph. But this way, we didn't have to do any guessing. Okay. B, 5x squared plus 6 equals 0. So remember, last time we got no real solution here. So let's see what happens this time. So if that is in standard form, which it is, x equals a negative b, but b is 0. So we're going to leave that off. Plus or minus the square root of b squared, but again, b is 0, so 0 squared just basically disappears. So a negative 4 times a, in this case a would be 5, and then c would be a positive 6. And then all that over to a. So therefore this is going to be plus or minus the square root of 4 times 5 is 20, times 6 is 120. Then we got a negative, and 2 times 5 is 10. And of course, you can't take the square root of a negative number. That would give us an imaginary number, which we're not doing anything with at this point in time. You'll do with that more probably in Algebra 2. And so we say no real solution. Anytime you have the square root of a negative, no real solution. And that's why in the graph we don't say just no solution, we say no real solution, because of what happens in the formula. All right, moving on to C. For letter C, I have x squared minus 10x plus 25 equals 0. So again, this is in standard form. It is equal to 0. So therefore, x equals a negative b. Now this time I do have a b. It's a negative 10. So a negative negative 10 would be a positive 10, plus or minus the square root of b squared, so negative 10 squared, minus 4 times a. A would just be 1. C would be 25. And I extend my radical to the end of that. All over to a. Simplify. 10 plus or minus the square root of, well, that'd be 100. And then 4 times 1 times 25 would also be 100. And 100 minus 100 is 0. And then 2 times 1, of course, is 2. Well, square root of 0 is just 0. So 10 plus 0 is 10. 10 minus 0 is still 10. And so this is really just 10 over 2, which is 5. So that's why we only have a single solution. So when that radicand, the stuff underneath the radical, turns out to be 0, we've only got one solution. Moving on to D. D we could use with the graphing calculator like they suggest. I'm going to continue though with the quadratic formula. That's really what I want to practice here. So D, we have x squared plus 64 equals 16x. Now this is not in standard form, and so I'm going to need to subtract 16x on both sides. So that I'll get an x squared minus 16x plus 64 equals 0. Now that it is in standard form, we can go ahead and use our formula. X equals a negative b, so in this case b would be a negative 16. So negative negative 16 is just a positive 16, plus or minus the square root of b squared, so negative 16 squared, minus 4a is 1, oops, c is 64, and I make sure my radical goes over the whole thing, and then all of that is over 2a, in this case 2 times 1. So simplify 16 plus or minus the square root, and so 16 squared, negative 16 squared, is actually 256, and then 4 times 1 times 64 is also 256. Well, 256 minus itself is 0. So actually, I don't need my radical to be quite so long. And that's going to be all over 2 times 1 is 2. So again, plus or minus 0 isn't going to do anything, so this is really just 16 over 2, or 8. So D just has a single solution. So remember what this means for my graph. This means that the vertex of our graph would actually be on the x-axis. Looking at E now. E says x squared plus 4 equals 2x. Again, this is not in standard form, so the first thing I need to do here is subtract 2x from both sides. And so x squared minus 2x plus 4 equals 0. So now x equals a negative b, so negative negative 2 is 2, plus or minus the square root of b squared, so that'll be negative 2 squared, minus 4ac, all over 2a. So simplify that. 2 plus or minus the square root of, now negative 2 squared is 4, and 4 times 1 times 4 is 16. 4 minus 16 is a negative 12. Of course, 2 times 1 is 2. Well, ladies and gentlemen, you can't take a square root of a negative, and so therefore we stop right there. No real solution. So what this would mean for us is, since this is opening upward, our leading coefficient is positive, it must mean the vertex is above the x-axis, and then it opens upward. F, round to the nearest tenth. So I have a negative 7x squared plus 3x equals negative 7. This is not in standard form, so the first thing I'm going to do is I'm going to add 7 to both sides to cancel out that negative 7. And so a negative 7x squared plus 3x plus 7 must equal 0. Well, x therefore equals negative b, so that'll be a negative 3, plus or minus the square root of b squared, so that's going to be 3 squared, minus 4, A is -7, and then C is a +7. And that will all be over 2A. So 2 times that -7 out front. All right, and here we go. So first things first, I see the -7, I see the minus there. Those actually can cancel. And so to simplify this, I'm going to have a -3 plus or minus the square root. Now 3 squared is 9, and 7 times 7 times 4 is 196. 196. So if we do 196 plus 9, we get 205. And that'll all be over a -14. So that right there, ladies and gentlemen, is the exact answer. That's the exact answer. Now, this asks us, though, to round to the nearest tenth. So if you have your calculators handy, to the nearest tenth, try to get that out of the way there. So for the numerator, I'm going to use parentheses. And I'm going to put in -3 plus, and then I'm going to do a square root of 205. I'm going to close that parenthesis for the radical. Then I'm going to close the parenthesis for the numerator. And then I'm going to divide that by a -14. So if I hit enter, that is one of my answers. So this equals a negative. Now round that off to the nearest tenth. So that'd be an 8 there. The 0 would tell me to round down, which round down really just means all that gets chopped off to zeros. So a negative 0.8. Or, now watch this. If I hit the second button, and then I come down here and I hit entry, so now we're looking at the yellow stuff, so above the enter button is entry, it will bring up the last entry, the last thing we typed in. So we did the plus. If I just move my cursor over here now, oops, one too far, and I highlight the plus, I can change it to a minus, and it's already all typed in for me. So I hit enter, and that's what happens when I do the minus. And so if I round that off to the nearest tenth, so the nearest tenth would be this 2. A 3 would tell me to round down, which really means just everything after the 2 becomes zeros. So 1.2. Now on a graph, if you were to graph this out, what you would see on your graph is that you'd have a value, or it would look like your graph hits the x-axis somewhere between 0 and 1, or excuse me, 0 and -1. And so you would maybe try 0.9, try 0.8, try, or excuse me, -0.9, -0.8, -0.7, and see which one of those is closest to 0. Over here on this side, you would look and it would look like your graph goes through the x-axis somewhere between 1 and 2. So closer to 1. So you'd try 1, you'd try 1.1, you'd try 1.2, 1.3, and you'd see which one of those was closest to 0. But if we use the quadratic formula, it's just nice and neat for us. All right, and last example, G. Marka shot an arrow while standing on a platform. The path of its movement formed a parabola given by the quadratic equation h equals a -16t squared plus 2t plus 17, where h is the height in feet and t is the time in seconds. Find the time when the arrow hits the ground. Round to the nearest hundredth. So I want to know what hits the ground, so the ground would be height 0. So we're trying to solve 0 equals a negative 16t squared plus 2t plus 17. Well, that is in standard form. Now, normally we write the equals 0 out the other side, but that doesn't really matter. The symmetric property of equality tells me it doesn't really matter which side of the equal sign things are on. They're still equal. So I can switch the left side and the right side of the equal sign, it's still equal. So therefore, since it's in standard form, we can go ahead and use our quadratic formula. And so we'd have x equals a negative b, so in this case a negative 2, plus or minus the square root of b squared, so 2 squared, minus 4a is a negative 16, c is a positive 17. And that is all over 2a, so 2 times the negative 16. So simplify what we can here. We're going to have a negative 2 plus or minus. Now for that inside stuff there, I might grab my calculator and just make my life a little easier. You can literally just type it straight in. So 2 squared minus 4 times a negative 16 times 17. So we get 1092. So the square root of 1092 all over 2 times 16 is 32, but it's going to be a negative. Now again, ladies and gentlemen, we want to round to the nearest hundredth here. So if I type in that equation, I'm going to use a parenthesis for the numerator, negative 2 plus the square root of 1092. That first parenthesis closes the radical, the second one closes the numerator. Divide by a negative 32, and so I get to the nearest hundredth, it can be a negative 0.97. And then if I hit second enter to bring up that entry, I can then go back, oops, too far again, and change that to minus now, hit enter again, and so with a 5 there, the 5 would tell me to round up, so the 9 would turn into a 10, which would leave behind a 0 and then carry over to the next spot. So 1.10. Now I'm not going to circle that because this is coming from a story problem. This is a real world situation. So we need to consider, do these values make sense? So if we're asking how long is it going to take to hit the ground, it doesn't make sense to go back in time. So the only answer here that makes sense with this real world situation is this answer right here. So my answer to G is going to be 1.10 seconds. And that, ladies and gentlemen, is the end of our lesson.